Alright, this is our review for the last part of your post-test. It's on the review packet. We're actually going to go back to number 9, even though we've kind of moved ahead to number 15 already, because this question actually shows up on the second part of the test. So this particular question on the review can technically be done without the use of a calculator. Or maybe not. I'm not real sure. I haven't done it yet. But the idea is we need to find the zeros of the function. So this particular function, I don't know what it looks like quite yet, but something like this. Oh, not quite like that. Something like that, where it's a cubic function that's going to have 1, 2, 3 places where it crosses the x-axis, and remember these are called zeros. So you're going to use your calculator. You're going to plug this into y1, which I'll go through and show you here. Let's see, calculator. And then we're going to use our second calc feature to find the exact zeros. Now I will tell you on your test, it's a smaller polynomial, and they are not pretty numbers, so you're going to need to round however they say. If it says tenths or hundredths, please watch the directions. And here, let me go ahead and type in our function. So x to the third. We'll try a standard window at first when we're graphing and see if that helps. We might have to adjust. Things happen. Alright, plus, what's the rest of it? Oh my gosh, 4x minus 12. Minus 12. There we go. Make sure that all the signs are appropriate. And when I graph, and I'm in a, I think, standard window, yep, I can see that there's 1, 2, 3 zeros. Now this particular function has very nice, clean integer zeros. The one on your test will not. So I'm going to show you how to find the zero if it's not pretty. So second trace, and you choose the zero finder command, which is number 2. And then you need to, I'm just going to find this one because it's pretty much in the middle here. You need to bring your cursor so that it's slightly to the left, so in this case slightly above that x-intercept, or that 0. So my cursor is really, really slow, so I'm going to make it hop. 1, this is apparently negative 2, so if I go a little bit to the left of it, I'm going to go negative 2.5. Now, a little bit of a spoiler alert, right? Because I already know what the answer is, negative 2. So you would have just scrolled to the left until you got your cursor up here somewhere, and now the directions switch to right bound after you hit enter, and it says, are you to the right? And I'll go, not yet. So I'm going to hit my right arrow like you guys would. Get a little bit to the right of them, so in this case below the x-axis. And then when you hit enter one more time, it'll say guess, and you say sure, because you're close enough by hitting enter, and then turns out our zero is exactly at negative 2. So, like I said, on your test, it won't come out pretty like that. I can probably just change this function slightly, and then we'll have something not pretty. Let's see. I'm just going to make this like a 5 and see what grossness I come up with now. Yeah. So in this case, I only have one x-intercept that I can see here. So if this is totally made up question, so it's not on your packet. Second trace, zero finder command. There we go. Left bound. Well, apparently I'm at 0, negative 12 right now, which I'm already to the left, but I'm a little far away. So I'm actually going to use my right arrow. Bring it on back. Okay, slightly to the left of the x-intercept. Enter. And then right bound. Slightly to the right. Enter. You can't see them too well, but there are 2 blue lines that are surrounding the x-intercept. Enter one more time. And I'm going to write down 1.11, or whatever the directions say to round to. So hundredths would be 2 decimal places, 1.11. Again, that was a totally made up question. I just changed it to. That's the kind of thing you're going to see on your test. Oh, by the way, I've been bad about telling section numbers. This is section number, oh gosh, I'm going to forget what it is. Ooh, is it 5. I'm going to say 5.2. It's also in section, oh gosh, be golly, it might be 5.6. It's one of these two. It's graph analysis, and it shows up actually a couple different places in our curriculum. So if you want extra practice problems, frankly, I just make up my own problems with my calculator and mess around with finding the x-intercepts. Alright, solving a logarithmic equation. We've been hitting this one hard too recently. So this is section 7.5b. And the idea is you need to what we call exponentiate in order to solve for x because it's trapped in a logarithm. So the only way to undo a logarithm is to apply the inverse function of a logarithm, which is an exponential function. So I choose the same base of my logarithm, and I use that to shove underneath each side of the equation, just like this. So what you guys have right now is 3, but up in his exponent now is log base 3 of x minus 8. So you might be asking yourself, and this over here is 3 to the 4th power. Like, why is that better? Well, 3 to the log base 3, these cancel. And then the x minus 8 just drops down. And this is where kids sometimes will make a mistake. This is 3 to the 4th power. So this is not like a 12. You have to possibly type that in your calculator, and that should be an 81, right? So if we add 8 to the other side now to solve, we get x equals 89. Lovely. That was 7.5b. This is the other side of 7.5. This is 7.5a, and these are solving exponential equations. Now this particular question, 2 methods. The method that most students like the best is to apply a logarithm or a natural logarithm. Whoops, that says natural logarithm. There we go. The other method is the baby base method, common base method. They're both correct, and they end up with the same exact math, so whatever makes you happy. So I'll do the logarithm method first, because that's how most of my students appreciated this question. If x is trapped in the exponent, the only way to bring it down is to apply a common or a natural log. And since you all are stinkers and you go against me every time, I'll use a common log just like you do. And then, I don't know why. Well, you know why I like natural log better. Come on. All right, the 2x minus 3 comes down in front. Leave it in parentheses for now. And what you have here, this does not cancel, by the way. It's common log is base 10, so that does not cancel. You have the common log of 5, which is some gross number. And then over here, again, common log of 625, again, a gross number. But don't type it yet, because some amazing things are going to happen. If you're trying to solve for x, well, the first thing I'm going to do is I'm going to divide this log 5, this gross number, over to the other side. And I'm going to type this in my calculator very carefully. Log of 625, close that logarithm, divided by log of 5. And you end up with, I should know this off the top of my head apparently, you end up with 4. So we have 2x minus 3 still equals, now it equals a 4. So when I add 3, and then divide by 2, I get x equals 7/2, or if you wrote down 3.5, that's totally fine. Now the baby base method, which is my method of choice, because I recognize that 625 is a 5. It's 5 to the 4th power. So I rewrite the whole equation as 5. So 5 to the 2x minus 3 can stay as it was, but 625 becomes 5 to the 4th power. And then look what I get to set up. 2x minus 3 has to equal 4. The only way for that to work is if those two equal each other. So basically I skip a whole bunch of work, and I get down to that step right away. So I'm still going to get 7/2. Same answer. Technically the same process, it's just we're interpreting the question a little differently. So if you recognize the common base and you feel comfortable doing that question that way, go ahead. Some of you have tried that method and not done well, so you need to pick a method that you can execute effectively. All right, careful, I don't actually want you to solve this, guys. I just want to know what the excluded values are. So this was section, well, it was a part of section 8.6 where we're solving, but the thing we started off doing every question with was you looked at the denominators and you remember that you cannot divide by a 0, right? You can't have a 0 in the denominator. So basically I set up that mentally, or literally set it up. I say x minus 7 cannot be 0, and then I set up x squared minus 49 cannot be 0. So your job is to tell me what x can't be. So if I kind of solve this anti-equation, I get x can't be 7. And then here you can either square root or factor it, but this factor is pretty nice, right? X plus 7, x minus 7. So this one gives me that same 7 again, but also a negative 7. So if I start making a list of things that I can't have as answers, those are my excluded values. So I say x cannot equal plus or minus 7. That's all they want in that question. Some of you go to the extra effort of actually solving it, and that's silly. Don't do that. All right, the job offer question. We've seen this quite a bit, especially on our tests back in the winter. And I give you 2 models. They're representing the job offers from Campco and Walby. So here's Campco, and they have this flat raise idea of you start at 30,000 and they're going to give you a flat linear raise of 800, so it's going to grow like this. And then there's Walby, which starts off with less money, 20,000, quite significantly less, right? But it's going to grow exponentially, so you're going to see this shape. So the idea is, while Walby starts off with less money, at some point in time, you're going to start making a lot more money at Walby, and your job is to figure out at what point in time are we talking. I mean, if we're talking like 25, 30 years from now, maybe it's not worth it to you to stay there. But if it's, within the first few years, and you plan on staying at this job for that long, then that's part of your reasoning. And this is where you guys have to choose, and you have to give me an example of how long you want to stay. And actually, the question will say, how many years later will one's salary exceed the other. So I know Walby pays less money for the first couple of years, but we need to figure out the point where one overtakes the other. Now you guys typically solve this by looking at the tables and comparing them, but I'm going to show you another method, and I think you might enjoy. So on your graphing calculator and your graphing screen, program your two functions. It was 30,000 plus 800x, I think. Just type carefully. And you don't have to use the graphing option. If you want to keep using the table, you sure can. 20,000, and then is it 1.07? Let's see, 1.06, my bad. Because they're going to have an exponential growth, so to the x power. And again, go ahead and look at the table if you want, but sometimes your answers were a little weak when you looked at the table. If you just hit graph right now, I have a standard window, and the reason I'm not seeing anything is because when you go to window, okay, it's only looking from -8 to 8 years. Well, first of all, why would I go negative? So I'm going to go 0, and then I'm just going to go like 40 years, because I hope I don't have to stay at this job for more than 40 years, but whatever, we'll figure it out. And then -5 to 5 for y, that's measuring how much money I get paid. So you're only looking at $5. I'm pretty sure you get paid more than $5, right? So I'm going to show you a trick though, guys. If you've set up your x's appropriately, you don't have to do anything with the y's. You can just do zoom fit. So choose a good x window and then go zoom, and then the 0th choice is called zoom fit. Choose that one. And it's going to adjust the y's to match your window. So there's the linear one, there's the exponential one. Your job is to find when one overtakes the other. So I'm going to use that intersect feature in the calc menu. So second trace, intersect, which is 5, and then you just hit enter 3 times. Enter, enter, enter. So this gives you a super accurate answer. So 11, we'll round it to 11.6 years. They're going to match pay at a roughly $39,000, but after, so once you hit like the 12th year of work, you're going to be paid more money at Walby. So you need to incorporate that answer into your answer. So if your answer is, I'm going with Camco because this is a starter job and I am not staying here longer than 5 years, and clearly Camco is going to make more money throughout those 5 years, then that's your answer. But if this is your long-term job and you want to stay here for your whole career and you're willing to stick it out for whatever 12 years that you need to be underpaid, then that's part of your answer as well. So you choose how you answer this. It is definitely your option, but you have to explain it here. So I'm going to be looking for that year mark. If you said between 11 and 12 years as an answer, that's okay. I'll accept that. But the full point comes from you explaining this part up here. So I can't really give you an answer to that because there's so many different answers. This question, however, there better be just one answer. And the one on the test is super obvious, so don't try to get creative, guys. I want to know how your parents and you guys feel about start times for the school day. Would I give a survey, an observational study, or an experiment? Well, clearly that's a survey. You can't observe people starting school at different times. That doesn't really work. You can't have an experiment where you unknowingly start people an hour earlier than everybody else, like they're going to figure that out. A survey makes the most sense. This one about sampling. So they want to know how healthy all the students are. So they collected a sample of students from all the fit classes, which from what I understand are typically kids who really enjoy physical fitness and like to work out and sweat during gym class. So I just don't know if that's a good sampling, because these guys are not necessarily representative of everyone at Harlem. I mean, if everyone took a fit class, then sure, you're hitting the entire population and not just a sector of it. So no, it's not a good method. So your job is to explain a better method of sampling. So what I want to see is what I have normally seen from you guys is an explanation of how you're going to use advisories, but remember it has to be a sample. You can't say I'm going to interview everybody. So as an example, many of you have said that you're going to number the advisories, advisory classes. And I don't know how many there are, but we'll say, 40. I'm making that number up, I think. 1 to 40. Have a random number generator select, oops, you can't read that, select 10 classes and distribute the survey to those advisories. So again, ideally you would just survey everybody because we have a small population. However, it did say I had to sample. So you had to choose a method for sampling. And that's always a good go. You guys are really big fans of using the advisories because I think you see that all the time in your own advisory. Alright, here we go. Probability. This is the one where we did some highlighting. You really have to understand the difference between and versus or, and then versus the given question. So overweight and female means you go to the chart, you pull one number off of it, and your denominator is going to be the full 112. So overweight and female would be these 21 ladies right here, which I think that does reduce a little bit. I don't care if you reduce it on the test, frankly. I just am happy if you set it up and leave it. But it is 3/16, so I don't care. Either answer, these are good. Or, however, still uses that same denominator, that 112. But or is a little different. You're going to take all the females plus all the overweight people, and then you're going to subtract the overweight females because you counted them twice. So all the females would be 50. All the overweight individuals, 66. But these 21 ladies were counted twice. So 50 plus 66 minus 21 is 95. So that's our numerator out of the 112 total. And is the one where you have to do some highlighting and you restrict your population. Excuse me. So, where's my highlighter? Why am I on a small screen? Oh goodness. Alright, here we go. Highlight. It says given, what does it say? Given male. So you're only going to be looking at the data from the male row. That's the only set of data you can use. So I see my denominator is going to be a 62. But in that data, how many people are overweight? It would be these 45 guys. And again, if it reduces, cool. If not, leave it. Frankly, I'm good if you just leave it unreduced. Excuse me. My goodness. That's a Starbucks pink drink you hear, huh? Alright, the theater company reviewed 3 surveys of people's movie preferences. So they have data from 3 different surveys. We got to compare them, and the best way to compare them is to look at percentages. So comedies. 56 out of 120, which if I convert that to a decimal or a percent is 0.47, so 47%. And then we have, what do we have next? Drama. Dramas, 80 out of 150, which is 0.53 or 53%. And then we have sci-fi. And I appreciate if you guys show me this math, because if you make a mistake, maybe I can figure out what you did. But this is one of those, like, get it right or get it wrong moments. Remember, your post-test is being graded traditionally, which means you just have to be perfect all the time. So good luck. Alright, 26 out of 60 is 43%. It was not a very uplifting speech from your teacher, sorry. So comedies and dramas, those are the 2 highest percentages, and that's my answer. Alright. This question, this next one, I really like. It's an error analysis question, and there are a few different answers you can give me for what did Jackie calculate by accident, but think about mistakes that you've seen your classmates make before. Remember, this line here means given. So, newspaper given male. What Jackie was supposed to do was she was going to highlight the male data, which is here. And I will warn you, they didn't total it for you, so you might want to do that. This is 20 and this is 20. 20 females and 20 males. So a grand total of 40 people were surveyed here. Jackie was supposed to do newspaper given male, so she should have done 5 out of 20. So I'm going to go ahead and do that here. 5 out of 20, which, yes, you can reduce to 1/4. So I don't really care what answer you give. I actually prefer the unreduced answer because I can see your work a little better. But she got 1/8, so she's quite off. And if I look at her original setup, she has 5 out of 40. So she used the big total, which is the only time you use that big total is when you're using an and or an or style question. So if I think about her numerator being 5, that part was correct, but then she used out of total, Looks to me like Jackie calculated the probability of newspaper and mail. Because remember, and or are the only ones that use the total. And clearly that's not an or. I don't know why she would have got a 5 with an or. So as her teacher, it looks like she just got given an and confused. Alright, so that was a little challenging because you do have to look at the wrong answer and figure out what they did by accident. I will tell you the most common mistake for the given ones are children who use the wrong part. Like if it says given mail, instead of highlighting the mail data, they'll highlight the newspaper data by accident. So she would have said like 5 out of 9. And that would have been, poor Jackie calculated mail given newspaper. She got these backwards. So I will tell you from experience as your teacher, that's the most common mistake that you will run into from other students and also often on error analysis questions. Alright, so that's your post-test, and that's a big chunk of your final exam. Oh, you know what I forgot to do is tell you all these sections. My bad. Okay, so this section here, this is probability calculations, and this is section something, there we go, 11.2 and technically 11.4 where the conditional probability hits. And then so is this and so is this. So all of these are 11.2 and 11.4. Probability and probability calculations. This is experimental design. I think this was section 11.8 in our textbook. And if you look on your testing itself, I think we just called it experimental design. These aren't necessarily difficult questions, but you know, some of you found that the wordier you got, the better your score, because you just kept writing until I was sick of grading it. Alright, this is section 7.1, 7.2b, the applications of growth and decay. This, we said, was section 8.6, and I think I actually numbered it before that, so I did a good job and then I stopped again. Man. Alright. So, that's part 2 of your post-test. Second day, it seems a little shorter, and it is, but there's a little more thinking and writing, I think, in these questions, so I felt like number 14 was a good time to split them. Alright, good luck, everybody. This is, one of the last things I'm going to record for the year, so I'll see you on a review for the multiple choice test, and after that, Abruzzo out.